Okay, now in the last chapter, in the last topic, what did we do? We have already done in this entire chapter, we did the introduction, then after that, the classification of matter, then significant figures, fundamental properties, derived properties, and the mathematical operations which are used for significant figures. We also did the Dalton's atomic theory, and according to that, we also did the laws of chemical combination. Now, today we are going to go to the next topic, Avogadro's hypothesis. If you remember, just take a recap that what did Dalton say? Dalton said that whenever any two atoms are combining to form a molecule, then they do so in a whole number ratio by weight. That is what Dalton said. Whenever there are atoms combining, they do so in a whole number, simple whole number ratio by weight. And what did Gay-Lussac say? Gay-Lussac said that if there is one gas combining with the other gas to give us another gas, the product is also a gas, two gases are reacting to give us the product as a gas, then they do so in a simple ratio by volume. So, Dalton's atomic theory kept into consideration the weight, whereas the Gay-Lussac's theory kept into consideration the volume. There was another scientist, Berzelius. What did Berzelius do? He combined both the Dalton's and the Gay-Lussac's theory, thereby saying that if we are taking an example of hydrogen plus chlorine to give hydrogen chloride, right? So hydrogen and chlorine to give hydrogen chloride. In this we are saying that according to Gay-Lussac's, one volume of this is combining with one volume of this to give us two volumes of hydrogen chloride. And according to Dalton, what did he say? If we are saying that one atom of this is combining with one atom of this, so that is going to give us what? It is going to give us a compound atom. In fact, two compound atoms, right? And if we are saying that half an atom of this is combining with half an atom of this, then this is going to give us one compound atom, right? But this shows what? That if you're taking half an atom of this, that when we say that we have to divide the molecule of hydrogen into half and half, two atoms. Similarly, chlorine also has to be divided into half and half, two sections of atoms, which according to Dalton was not possible. Why? Because Dalton said the atom is anything which is indestructible, which cannot be subdivided into smaller parts. To come over this confusion, Avogadro said that any matter is formed of two different type of substances or two different particles. So he defined, Avogadro's defined two different particles. So what are we saying? That Avogadro, he gave a conclusion to this confusion that every atom is the smallest particle which composes the entire matter. He says that matter is composed of two different particles. So what are those particles? The first one is atom, right? So he says that atom is the smallest particle which which participates in a chemical reaction and may or may not have. So it is the smallest particle which participates in a chemical reaction and it may or may not have independent existence. It may or may not have independent existence. For example, when we are talking of oxygen, oxygen does not exist in the form of atom because oxygen does not have independent existence. But noble gases have independent existence. Metals also have independent existence. Then the second thing which he said was, the second particle was molecule. The second particle was molecule. So he says molecule is again the smallest particle which participates in a chemical reaction, but the difference is that a molecule has independent existence, right? So molecule basically is nothing but it is compound atoms as was put forward by Dalton. Atoms combine together to form a molecule. Then Avogadro put forward his hypothesis. He said that under similar conditions of temperature and pressure, equal volumes of all gases contain equal number of molecules. So what is Avogadro's hypothesis? Under equal conditions of temperature and pressure, equal volumes of all gases contain equal number of molecules. Right? So this was the Avogadro's hypothesis that under equal conditions of temperature and pressure, equal volumes of all gases contain equal number of molecules. So if we are taking the same example again, that is hydrogen plus chlorine to give us 2HCl. So here we can see one volume of this is giving us 2 volumes of HCl. If we are taking one molecule, so one molecule is giving us 2 molecules. And if we are taking half a molecule, so this is going to be half molecule and half molecule to give us 1 molecule. This is the Avogadro's hypothesis, right? Now, what are the applications of Avogadro's hypothesis? Let's see. Applications of Avogadro's hypothesis. Applications. Now, when we're talking of applications, the first application of Avogadro's hypothesis is that it gives us the atomicity of gases. What do we understand by atomicity? Atomicity का मतलब होता है कि कितने atoms एक molecule में present है, उसे हम atomicity बुलाते हैं, ठीक है? जैसे for example, अगर हम कोई भी noble gas लें, जैसे हम argon ले रहे हैं, तो argon independently exist करती है. Therefore, its atomicity, it has only one atom. Its atomicity is 1. its atomicity is going to be 1, and such gases, they are said to be monoatomic in nature. Monoatomic in nature. Then we have diatomic gases. For example, hydrogen, oxygen, hydrogen, nitrogen. All these have 2 atoms. Therefore, the atomicity of such gases, it is going to be 2, and such gases, they are said to be diatomic in nature. Right? Then the third one is ozone. Ozone has 3 atoms. So atomicity, that is going to be 3, and such gases are said to be triatomic in nature. So Avogadro's hypothesis helped us to calculate the atomicity of gases. फिर उसके बाद सेकेंड उसने हमें रिलेशनशिप दिया बिटवीन मॉलिक्यूलर मास एंड वेपर डेंसिटी. उसने हमको रिलेशनशिप दिया बिटवीन मॉलिक्यूलर मास एंड वेपर डेंसिटी. अब अगर हम लोग वेपर डेंसिटी को डिफाइन करें तो हम बोलते हैं कि वेपर डेंसिटी दैट इज द रेशियो ऑफ डेंसिटी ऑफ द गैस अपॉन डेंसिटी ऑफ हाइड्रोजन. राइट? नाउ वी नो दैट डेंसिटी मास के ऊपर डिपेंड करती है. तो अगर हम वॉल्यूम को कांस्टेंट रख लें तो यहाँ पे फिर वेपर डेंसिटी क्या आ जाएगी? दैट विल बी इक्वल टू मास ऑफ द गैस एट अ स्पेसिफाइड वॉल्यूम अपॉन मास ऑफ हाइड्रोजन एट द सेम वॉल्यूम. सो हम यहाँ पे वॉल्यूम को कांस्टेंट कर रहे हैं. मास ऑफ हाइड्रोजन एट सेम वॉल्यूम. राइट? सो हम क्या बोल रहे हैं कि वेपर डेंसिटी क्या है? इट इज द डेंसिटी ऑफ द गैस अपॉन डेंसिटी ऑफ हाइड्रोजन. अगर हम वॉल्यूम कांस्टेंट कर लेते हैं तो डेंसिटी जो है डायरेक्टली प्रोपोर्शनल टू मास हो जाएगी. सो हो गया मास ऑफ द गैस अपॉन मास ऑफ हाइड्रोजन एट द सेम वॉल्यूम. फिर उसके बाद अगर हम मास ऑफ द गैस ले रहे हैं, लेट्स टेक मास ऑफ n मॉलिक्यूल्स ऑफ अ गैस. Mass of n molecules of a gas upon mass of n molecules of hydrogen. Mass of n molecules of hydrogen. ठीक है? फिर उसके बाद अगर हम n molecules लेंगे तो obviously अगर हम one molecule को into consideration ले रहे हैं तो that is mass of one molecule of gas upon mass of one molecule of hydrogen. Mass of one molecule of hydrogen, right? या otherwise अगर mass of one molecule of gas upon mass of one molecule of hydrogen हम लेते हैं तो हम यहाँ पे ग्राम मॉलिक्यूलर मास ऑफ द गैस अपॉन ग्राम मॉलिक्यूलर मास ऑफ हाइड्रोजन भी ले सकते हैं. तो वेपर डेंसिटी फिर क्या आ जाएगी? वेपर डेंसिटी इज इक्वल टू मोलर मास and the molar mass of hydrogen has to be taken, which is equal to 2. Right? So what is the relationship between molar mass and vapor density? We say that molar mass is equal to 2 into डेंसिटी, राइट? सो दिस इज द रिलेशन जो कि हम लोग यूज करेंगे आगे एम्पिरिकल फॉर्मूला में। सो इस तरह से हमें एवोगैड्रो ने क्या दिया, एटॉमिसिटी ऑफ द गैसेस दे दी और रिलेशनशिप बिटवीन molecular mass and vapor density. How do we calculate the vapor density over here? उसके लिए दो मेथड्स रहते हैं जो कि हम लोग ऑर्गेनिक केमिस्ट्री में करेंगे। The first one that is known as Victor-Mears method और second वाला जो है that is Dumas method. ठीक है? Okay, so the third application is he gave us gram molecular mass, sorry, gram molecular volume. ग्राम मोलिकुलर वॉल्यूम। अब ग्राम मोलिकुलर वॉल्यूम को हम लोग किस तरह से कैलकुलेट करेंगे? इसको हम कैलकुलेट करते हैं बाय टेकिंग द डेंसिटी ऑफ हाइड्रोजन और डेंसिटी ऑफ हाइड्रोजन दैट इज इक्वल टू 0.00009, राइट? और 9.0 into 10 raised to power minus 5 grams per ml. So उसी से हम लोग ग्राम मोलिकुलर वॉल्यूम को कैलकुलेट करते हैं। Let's say density of hydrogen that is equal to 9.0 into 10 raised to power minus 5 grams per ml. 9.0 into 10 raised to power minus 5 grams per ml. Now this is the density at 1 ntp. At ntp, right? So ये density हमने जो ली है ये ntp पे है और 1 gram of hydrogen अब कितनी वॉल्यूम ऑक्यूपाई करेगा? 1 gram of hydrogen occupies volume that will be equal to how much? That will be equal to 1 upon 9 into 10 raised to power minus 5. ठीक है कि अगर डेंसिटी हाइड्रोजन की 9 into 10 raised to power minus 5 grams per ml है तो 1 gram of हाइड्रोजन की डेंसिटी की वॉल्यूम कितनी हो जाएगी? 1 upon 9 into 10 raised to power minus 5, right? और 1 ग्राम मोल अगर हम लें 1 ग्राम मोल का वेट हाइड्रोजन का कितना होता है? दैट इज 2.016 ग्राम्स। सो ये कितनी वॉल्यूम ऑक्यूपाई करेगा? दैट विल बी इक्वल टू 2.016 upon 9.0 into 10 raised to power minus 5, right? Now when this is calculated it comes to 22400 ml or equal to 22.4 liters. Okay, so it was put forward by Avogadro's that 1 mole of every gas at STP occupies 22.4 liters volume or 22400 ml volume. So ये इसकी सारी की सारी तीनों जो थी ये अचीवमेंट्स की थी किसकी? एवोगैड्रोस की। फिर कई बार एक क्वेश्चन आपको आ जाता है that what do you understand by Loschmidt number? Loschmidt number क्या हुआ? Loschmidt number क्या होता है कि it is the number of molecules of a gas in 1 centimeter cube or 1 milliliter. Number of molecules of a gas which are present in 1 centimeter cube or 1 ml. Number of molecules present, right? अब हमें ये पता है कि liters or 22400 ml, इसमें कितने प्रेजेंट है? In this there are, according to Avogadro, 6.02 into 10 raised to power 23 molecules are present. So 1 ml में कितने प्रेजेंट हो जाएंगे, जो कि लॉस्टमेट नंबर है? In 1 ml it will be equal to 6.02 into 10 raised to power 23 upon 22400. ठीक है, और जब आप इसको कैलकुलेट करते हो तो ये आता है 2.68 into 10 raised to power 18 molecules. पर ठीक है, सो 1 मिलीलीटर अगर हम लेते हैं तो उसमें 2.68 into 10 raised to power 18 molecules are present, और इसको हम लोग लॉस्टमेट नंबर बुलाते हैं. क्लियर हो गया? सो दिस वाज द एवोगैड्रोस हाइपोथेसिस. एवोगैड्रोस हाइपोथेसिस में एक बहुत ही इंपॉर्टेंट कॉन्सेप्ट हमको दिया था, व्हिच वाज नोन एज द मोल. राइट, बेसिकली ये जो कॉन्सेप्ट मोल, द टर्म मोल वाज गिवन बाय ऑसवाल्ड एंड नॉट बाय एवोगैड्रो. ओके, सो ऑसवाल्ड वाज द साइंटिस्ट जिसने मोल के बारे में हमें बताया. सो लेट्स सी व्हाट इज द मोल कॉन्सेप्ट. Now as I just said कि एक मोल, जो मोल टर्म था, that was given by the scientist Ostwald. Basically क्या होता है मोल? मोल is just a kind of a property you can say, या एक fixed कोई स्कोर है जिसमें एक fixed number of particles है. जैसे फॉर एग्जाम्पल अगर हम लोग डजन यूज करें तो डजन का मतलब कितना होता है? 12. If we are saying 1 dozen pencils, so that means 12 pencils. 1 dozen bananas means 12 bananas. 1 dozen eggs means 12 eggs. In a similar manner, अगर हम लोग 1 unit gross लें, तो 1 unit gross जो है उसके अंदर 144 articles present रहते हैं. 1 unit gross, there are 144. In a similar manner, अगर हम लोग सेंचुरी लें तो सेंचुरी के अंदर 100 particles present रहते हैं. तो मोल जो था वो यही कॉन्सेप्ट था कि एक मोल के अंदर कितने पार्टिकल्स प्रेजेंट होने चाहिए. तो इट वाज एक्सपेरिमेंटली डिटरमाइंड दैट 1 मोल basically is defined as the number of atoms present in carbon 12. Number of atoms present in carbon 12, and in this the atomic mass that was considered in 12 grams of carbon 12. Experimentally this was determined to be as 6.02 into 10 raised to power 23 atoms were present. So this was taken to be as a fixed number कि अगर हम 1 मोल ले रहे हैं तो 1 मोल comprises of 6.02 to 10 raised to power 23 entities. अब वो entities atoms हो सकती हैं, वो entities molecules हो सकती हैं, वो entities ions हो सकते हैं, और वो entities formula units भी हो सकते हैं. So that is what 1 mole is. For example, if we are taking 1 mole of argon, so we know that argon exists as what? It exists as atoms, क्योंकि नोबल गैस है, तो इसके पास 6.02 into 10 raised to power 23 atoms present रहेंगे. अगर हम 1 मोल ऑफ ऑक्सीजन लेते हैं तो ऑक्सीजन मॉलिक्यूलर फॉर्म में एग्जिस्ट करता है, तो इसके पास 6.02 into 10 raised to power 23 मॉलिक्यूल्स रहेंगे। अब अगर हमको एटम नंबर ऑफ एटम्स कैलकुलेट करने हैं ऑक्सीजन के अंदर, तो हम 6.02 into 10 raised to power 23 को उसकी एटॉमिसिटी के साथ मल्टीप्लाई कर देते हैं। तो इसका मतलब क्या हुआ, 1 whole is equal to 2 into 6.02 into 10 raised to power 23 atoms, right? In a similar manner, अगर हम लोग 1 whole of electrons लें, तो 1 whole of electrons में कितने इलेक्ट्रॉन्स प्रेजेंट होंगे? 6.02 into 10 raised to power 23 electrons are going to be present in 1 mole of electrons, right? So इस तरह से हम लोग करते हैं कि 1 mole of every substance has 6.02 into 10 raised to power 23 entities. अब अगर हम लोग मोल को देखें, तो 1 mole of anything that consists of these many atoms and 1 mole of anything will be equal to the atomic or molecular mass. For example, if we are taking argon, so argon ka 36 is the atomic mass. So 1 mole of argon is equal to 6.02 into 10 raised to power 23 atoms. So 6.02 into 23 atoms का weight कितना होगा? That will be equal to gram atomic mass, which is 36. Okay. Similarly, 1 mole of oxygen के पास molecules कितने हैं? 6.02 into 10 raised to power 23 molecules. तो इतने molecules का weight कितना होगा? That will be 32 grams. Weight of 1 gram molecule of oxygen. Similarly, अगर हम 1 mole of electrons कर रहे हैं, तो 1 mole of electrons का mass कितना होगा? 1 electron का mass होता है 9.11 into 10 raised to power minus 31 kg. So इसमें 1 mole of electrons का mass कितना हो गया? 6.02 into 10 raised to power 23 into 9.11 into 10 raised to power minus 31 kg. So this is the mole concept. Now how are we going to calculate the number of moles? पर उससे पहले एक और चीज हमारी रह गई कि अगर हम लोग सपोज गैसेस कंसिडर कर रहे हैं, तो 1 mole of every gas, in fact 1 mole of any gas at STP, it will occupy how much volume? It is going to occupy 22.4 liters of volume, right? Or 22400 ml of volume, right? So 1 mole of any gas at STP will have 22.4 liters of volume. So if we have 1 mole of oxygen, it contains 6.02 into 10 raised to power 23 molecules, which will weigh 32 grams and which will occupy 22.4 liters of volume at STP, right? उसी तरह से एक और एग्जांपल ले लेते हैं। 1 mole of nitrogen, which is equal to 6.02 into 10 raised to power 23 molecules of nitrogen, which is equal to the gram molecular mass of nitrogen, 28 grams, and which is equal to again 22.4 liters of volume. ठीक है? So हम लोग irrespective of the gas, कौन सी गैस हम ले रहे हैं, 1 mole of every gas is going to occupy 22.4 liters. अब नंबर ऑफ मोल्स को किस तरह से कैलकुलेट करते